Hey people, welcome to my video. Thank you for clicking on this thumbnail. Thank you. And here, let's try to solve this problem. Maximum profit in job scheduling. No, it is the 20th problem from Leetcode's August monthly challenge. And then the question is pretty simple. There are some jobs, and each job has a start time and an end time and some profit associated with it. So our job here is to it's a good pun. So our job here is to find some jobs which are not overlapping, and we got to find the maximum profit we can get out of all these jobs. So for example, here we have some jobs with profits of 50, 10, 40 and 70. And here we need to find some jobs which are not overlapping. If we choose 50, we cannot choose 10 because 50 and 10 are overlapping. We cannot choose 40 either. We can choose 50 and 40, but we cannot choose 10 and 40 together because they are overlapping. And just by normal observation, we can say that this job of 50 and 70 would be most optimal because they are not overlapping, and then they would give you a total profit of 120, which would be the answer here. So whenever I see these problems, I think of these situations as either we choose to take this job or we don't take this job. That goes for every job. So whenever it comes to every job, we can choose to do it or not do it. So there would be 2 power n possibilities. And whenever there are so many possibilities, I think of recursion. And whenever we solve anything with recursion, we can always make it better using dynamic programming. So let's try to solve this problem using dynamic programming. The solution would be pretty intuitive. It would be self-explanatory. So let's go. Let's dig in. So let us start writing the code for it. Now, I tend to keep my code so neat and clear. So I'm going to create a class called as job, the capital J, of course, and then I'm going to implement its comparator so that I can compare it because I need to sort it, right? So I'm comparing all these jobs according to their start time, so I'm going to return this dot start time minus o dot start time. Now let me create these variables. Profit. And then let me quickly create a constructor with all these things. I need to return this. So our class is complete. So first thing I'm going to do is first I'm going to create an array of jobs. And then I'm going to fill in all these objects. After filling in the array, I'm going to sort it. And once the sorting is done, now I'm going to traverse the array from the back, and let me create a dp array. I'm going to define my dp state as dp of x would be the maximum profit I could get by considering the jobs from x until the end of the array. enough. So first, what would be dp of n minus 1? First make n is equals to start time dot length. What would be dp of n? dp of n minus 1, the last element. Now you could always choose the last element, because there would be nothing when I consider only one job. So dp of n minus 1 would be max profit I could get by considering all the elements from n minus 1 to n minus 1. So so that would be, there would be only one job to consider, and I would always choose it. Why won't I choose it? So that would be just the profit of that would be just the jobs of n minus 1 dot profit, and then I'm going to calculate using dp for all other jobs, for all other dp states from n minus 2. So for int I equals to n minus 2, I greater than or equals to 0, I minus. As I told you, I tend to keep my code clean and easier to understand, so I take cases. So the first case would be not considering that job. Not considering. In this case, so for example, so these are the jobs, let me say. So this is job 1, job 2, and job 3. For example, if I don't consider this job, then the max profit I could get out of all these jobs would be the max profit I could get from these jobs, right? Because I'm not considering this. So that would be just the dp of all the next elements. So that would be int case no would be just dp of I plus 1. This was easier, but the case of case yes would be a bit harder for us. So what I'm going to do is the same. Let me say we have these jobs, job 1, job 2, job 3, job 4. For example, if I need to consider this job, then this job might have an end time which might be greater than the start time of some of these jobs. For example, let me say job 1 takes time until here. In this case, I cannot choose job 2, because if I choose job 1, I cannot choose job 2 because that would be overlapping. In that case, if I choose job 1, I have to find a job from J2 until the end of the array where the job won't be overlapping. So for example, if this is the case, if J1 is overlapping with J2, then if I choose J1, I cannot choose J2. I have to choose jobs from J3, right? So I'm going to find this element J3, and then I'm going to add in the profit of J1 with the optimal answer of J3, right? So that would be for int j equals to I plus 1, j less than n, j plus plus. If I need to find an element where the jobs of j dot start time is greater than or equal to the end time of our current job. If I find such an element, I can stop, and I can choose. I could stop there, and then I could choose elements. I could choose the optimal answer from there till the end of the array. So case yes would be dp of j dot dp of j, and I could just break, because I know this array is sorted. So if this is the first element with this condition, all the other elements would follow this condition. So I could just do that. Yeah, as this array is a sorted array, you could use binary search instead of linear search to further decrease the time complexity of it, but I'm going to do that later. So and now I have to choose between these two cases. So dp of I would be the best of these cases. And once all these dp states are calculated, my total answer would be dp of 0, because that would be the max profit I could get by choosing jobs from 0th element till the end of the array, right? So I'm going to return dp of 0. Let me try if it works or not. Most probably it won't work, but let me just check. Let me paste in the code here. Let me check for any syntax critical errors. Okay, let me run. Oh, it gives the wrong answer. Let me see where we do where did we do wrong. Yeah, the thing is, whenever I'm using case yes, in that case I need to add in the profit of the ith job, right? That would be jobs of I dot profit. Now I think it will give it the right answer. Yeah. Hey, it's working. Yeah, let me check. 99.65, not bad, but we could make it better. As I told you all, that this array after sorting would be a sorted array. So instead of doing this linear search here, we could use a binary search, which would further increase the time complexity, which would further decrease the time complexity and make it more efficient. But I think yeah, you could do that if you want, but if I do that, this video would get too long, and yeah, people don't like watching long videos, So if you like this video, share it with your friends, subscribe would be good, and that's it. Ciao.